Hi everyone, this is a problem we choose from electric dipole. It said that a neutral water molecule is in its vapor state, and the dipole moment of magnitude is 6.2 into 10 to the minus 30 coulomb meter. Now the first question they ask you, how far apart the molecule center of the positive and the negative charges. That means the distance between the positive and negative charges. Second question, if the molecule is placed in an electric field of magnitude 1.4 into 10 to the 4 Newton per coulomb, then what is the maximum torque can the field exert on the dipole moment? So that's mean we have to also find out the torque in that water molecule if that molecule is placed in an electric field 1.5 into 10 to the 4 Newton per coulomb. Fine. Say for the first one, we are saying that this is the case for is given that your electric field for that case, which is 1.5 into 10 to the 4 Newton per coulomb. Magnitude of the electric dipole moment is 6.2 into 10 to the minus 30 coulomb meter. Then they ask to find out that distance between that positive and the negative charge, which we express by the R. And the second one, they ask you the torque, what would be the maximum torque on the case. Say for first one, we define that electric dipole moment using a system of charged particle, basically say I equal to 1 to n. It's a Qy Ri, right? So that is actually the expression of that electric dipole moment for a system of charged particle. And the magnitude, we can find out the magnitude of this one is basically P would be Q into R. So this would be our working formula, where R is the distance between that two opposite polarity charges. Say this is a plus charge, this is a minus charge, then the distance between that charge, say the R. Then we can write down this formula. Fine, they gave me basically this dipole moment magnitude. We are going to find out the R. Then what would be the Q for this water molecule? To find out that Q, say we have to express this water molecule, which is H2O. What would be the total charge over there? So I can say for oxygen atom, it has the proton number is 8, right? Then I can say that there are 8 proton plus 8 electron, right? And for hydrogen atom, we know that the proton number is 1. Then I can say that there is 1 proton plus 1 electron. But there are 2 hydrogen atom in water molecule. So that's why we can say this is the 2 proton and the 2 electron. In that case, the total charge would be the 10 proton plus 10 electron. So that means it's the equal number of that electron and the proton in the water molecule. So that's why we can say that the charge for this water molecule will be the 10 E or the proton, whatever you can say. Now then I can find out from R would be basically P over Q, which will give me P is 6.2 into 10 to the minus 30 divided by 10 into 1.6 into 10 to the minus 19. then I can find out that R. So R would be, if you do that calculation, you will find out R would be 3.9 into 10 to the power minus 12 meters. So that would be the distance between the positive and the negative charge inside that water molecule in that vapor state. Fine. What about the second one? For the second one, we know that the torque on an electric dipole we express by that formula, which is dipole moment cross electric field, right? This is vector product. And we can also write down the magnitude of this torque would be basically P sine theta. I'm sorry. And this will be that working formula over here. I take the magnitude of this torque. Fine. And we know that the torque would be maximum when your theta is 90 degree, right? The torque is maximum, you can write torque is maximum when theta equal 90 degree. So you can write that torque would be P into E, since sine 90 basically the 1. Then we can find out what will be the maximum value of the torque, because we know that P, which is dipole moment, the value of the dipole moment is 6.2 into 10 to the minus 30. 6.2 is a 6.2 into 10 to the power minus 30 into electric field is 1.5 into 10 to the 4. After doing that calculation, you can find out that maximum value of the torque on that water molecule would be 9.3 into 10 to the power minus 26 Newton meter. That would be the torque on that water molecule in this case. This is the answer of the question number B. Okay, thank you very much.